What are APIs? A computer scientist explains the data sockets that make digital life possible. APIs, or application programming interfaces, are the gateways to the digital world. They link a wide array of software applications and systems. APIs facilitate communication between different software systems and so power everything from social media. Think of the share buttons on web pages to e-commerce transactions. At a simple level, APIs are like electrical sockets. A software application that you are using, say the playback controls for a video on a web page, is like an appliance. The system that provides data or services that the application needs, say a YouTube, is like the electrical grid. The API, in this example the YouTube Player API, is like the standard electrical outlet that lets any appliance plug into the grid. APIs are not really so simple, though. Another analogy is a restaurant. The customer is the software application, the chef is the data or service, and the waiter is the API. The waiter brings the customer the menu, which lists available dishes, i.e., options for accessing data or service, and then brings the customer's request to the chef. APIs rely on defined rules and protocols that ensure accurate data exchange and effective collaboration. There are APIs for specific uses and software developer preferences. Why APIs matter? APIs power various applications and services across many diverse industries. Facebook, Instagram and Twitter, now rebranded as X, let users share their content across these social media platforms. By leveraging their social media credentials, users can log into websites, weather apps and games to simplify their online experiences. Amazon and PayPal depend on APIs for secure payment processing and efficient order fulfillment. Navigation services like Google Maps leverage APIs to provide real-time location data and accurate directions. Even voice-activated smart assistants like Amazon's Alexa and Google Assistant use APIs to manage and control smart home devices. A widely used API is critical for most mobile and web apps. Who has access to an API also matters. For example, in March 2023, X began charging a wider range of users for access to its data API, which lets users collect large numbers of tweets to see what people are tweeting about. Businesses use the API for market and competitive research, but many people with limited resources, like developers of some free apps and social science researchers, also rely on it. APIs are also playing a role in making artificial intelligence widely available. For example, Google, Microsoft and OpenAI provide APIs for software developers to incorporate AI in their products. As APIs continue to shape the digital landscape, developers face challenges. Ensuring the security and privacy of data exchanged through APIs is paramount, given their integration into critical systems. As APIs evolve, managing their complex ecosystems and making sure old programs can use new APIs will be a considerable task. A new framework for web scraping data to ensure its validity for use in marketing studies. Researchers from Erasmus University Rotterdam, Tilburg University, INSEAD, and Oxford University published a new paper in the Journal of Marketing that proposes a methodological framework focused on enhancing the validity of web data. The study is authored by Johannes Bogershausen, Hans Data, Abhishek Bora, and Andrew T. Stephen. The recent ruling of the Ninth Circuit in HiQ Labs v. LinkedIn underscores the importance of navigating the legal challenges when using web scraping to collect data for academic research. While it may be permissible to collect information from publicly available sites, researchers still need to be cautious about how they design their extraction software. For example, collecting information from publicly available user profiles in some jurisdictions may trigger privacy concerns and prompts researchers to anonymize their data during the collection. While marketing researchers increasingly employ web data, the idiosyncratic and sometimes insidious challenges in its collection have received limited attention. How can researchers ensure that the data sets generated via web scraping and APIs are valid? This research team developed a novel framework that highlights how addressing validity concerns requires the joint consideration of idiosyncratic technical and legal ethical questions. The authors say that their framework covers the broad spectrum of validity concerns that arise along the three stages of the automatic collection of web data for academic use: selecting data sources, designing the data collection, and extracting the data. In discussing the methodological framework, we offer a stylized marketing example for illustration. We also provide recommendations for addressing challenges researchers encounter during the collection of web data via web scraping and APIS. The article further provides a systematic review of more than 300 articles using web data published in the top 5 marketing journals. Using this review, the researchers explain how web data has advanced marketing thought. Understanding the richness and versatility of web data is invaluable for scholars curious about integrating it into their research programs. Interested researchers can access the database developed for this review on the companion website. This website also features additional useful resources and tutorials for collecting web data via web scraping and APIS. The researchers add that they use their methodological framework and typology to unearth new and underexploited fields of gold associated with web data. We seek to demystify the use of web scraping and APIS and thereby facilitate broader adoption of web data across the marketing discipline. Our future research section highlights novel and creative avenues of using web data that include exploring underutilized sources, creating rich multi-source data sets, and fully exploiting the potential of APIS beyond data extraction. Researchers standardize collection, reporting of wearable activity trackers data. Wearable activity trackers are not only popular with consumers but also commonly employed by clinicians for both real-time and remote monitoring of patients' physical fitness. When these devices are used as healthcare monitoring tools in medical research studies, however, there's an issue: inconsistency. To help remedy this, a team led by University of California, Irvine researchers has developed a framework for standardizing data collection and reporting. The study was recently published online in the International Journal of Medical Informatics. Activity trackers capture personalized data that can provide insights in healthcare analytics and user feedback on health status for both patients and healthy individuals, but there's a lack of standardization in reporting on the metrics they generate, said corresponding author Alexander Chan, ICHE Chair and Professor of Clinical Pharmacy Practice. These devices may revolutionize healthcare by allowing researchers to monitor symptom severity and assist clinicians in providing their patients more holistic care and, ultimately, improve people's quality of life, but the biometric statistics obtained can be highly variable. Our aim is to improve the consistency of reporting. The researchers' recommendations provide a minimum threshold framework for reporting adherence, validity, and physical activity measures in clinical studies. Several commercial trackers have been used in medical research, with the Fitbit being the most common. Brands integrate different sensors such as accelerometers, global positioning systems, and gyroscopes into the devices, and various algorithms are used to determine activity outputs, including step count, distance traveled, and sleep patterns. These personal biometrics are input into each individual's specific account, which can then be accessed directly or through third-party fitness applications. The team conducted a systematic review of observational or intervention medical research studies of both healthy and patient populations via the PubMed and Embase databases. Although inconsistencies were found in measurement and reporting data, commonalities and definitions of the types of activity tracker-derived measures were identified to develop recommended minimum reporting thresholds. Key metrics were adherence data, or the percentage of days the trackers were worn; validity period, or the adequate wear time per day and per week; and physical activity measures, including step count, acceleration levels, energy expenditure, and intensity. With the growing use of activity trackers in clinical research, our framework may help facilitate the development of standardized data collection and reporting. Our recommendations are the first step. Currently, we are applying our recommendations to a set of medical tracker data that we've collected from an international study involving adolescent and young adult cancer patients and volunteers. Future studies will need to evaluate the feasibility of adopting minimum reporting thresholds for data generated by these wearable devices, Chan said. Physical activity monitors do help boost activity levels in adults. Physical activity monitors, such as fitness apps and wearable activity trackers that provide direct feedback to users, do help to boost activity levels in adults, finds a summary of the evidence published by the BMJ today. The effects are small to moderate, equal to 1,235 extra steps a day and almost 50 extra minutes of moderate to vigorous physical activity a week, and the certainty of evidence ranged from low to moderate. But the findings suggest that these devices may be useful at a time when many adults don't meet recommended activity levels. Modern physical activity monitoring devices have the potential to change people's behavior, but